Hey guys, Mrs. Trevor here. We're going to walk through our notes on 30, 60, 90 triangles. Sorry for the technical difficulties. There we go. Let's clear this out and light up the screen. There we go. So here's our game plan. We're going to talk through 30, 60, 90 triangles, but before we start talking about those right triangles that are special, let's talk about a different type of triangle, an equilateral. Equilateral triangles have two qualities. They have equal side lengths. So I could fill those side lengths in. Let's decide, I don't know, all these sides, let's let them be 2. They're equal, so we can put those marks in. Equilateral triangles also have equal angles. So I could put these marks in. If all of those angles are equal and the angles inside a triangle add up to 180, then I know that all of those angles must be 60 because 60 degrees plus 60 degrees plus 60 degrees is 180. So this looks pretty good. Our game plan here is we're going to kind of think of this equilateral triangle and look at a part of it, half of it specifically, as a right triangle. So I want to actually look at this half of the triangle, and I'm going to redraw it below. So I'm talking about this triangle. If I were to cut down perpendicular to the base and make a triangle that's just half that size, we can fill in some of the info. Like, for example, this side is still 2. And then this bottom side was 2, and now it's cut in half to be 1. We also know this angle is the same angle, so that's also 60. And this top angle was 60, but it got cut in half, and now it's 30. Now we've got almost all the info about this triangle, except for the fact that we don't know this length here for the height, but we can find that pretty quickly. Let's use the Pythagorean Theorem to do that. So I could use this leg and this leg I don't know. We'll call it x to say 1 squared plus x squared is 2 squared. And let's simplify a little bit. That would mean we've got 1 plus x squared equals 4. And we'll take away the 1. So x squared is 3. Lastly, let's get rid of the squared by square rooting both sides and say x equals the square root of 3. Now, technically, I should put a plus or minus here, but because we're talking about a length in geometry, we don't have to worry about that. I know that I'm not going to have a negative length, so I can say with confidence this is the square root of 3. So now what we've got here doesn't seem very cool, but it actually is pretty cool. This triangle is going to be pretty special. It's called a special right triangle, but what we've got here is a triangle that we can refer back to for any other 30, 60, 90. So for every other triangle that's got the angles 30, 60, and 90, it's really this triangle, but just bigger or smaller by some factor. So if we can figure out what the scale factor is, then we should be able to solve for any of the side lengths pretty quickly, knowing that they're multiples of 1, 2, root 3. So that's what we're going to do. We're going to do 3 examples on these notes. So let's get into the first one. Our first one, I'm going to get it set up pretty similar to the last. And here's the info I'll give us is that we've got this 60 degree angle as well as the side length 3 root 3. So let me put both of them up at the same time. There we go. Here's what we're thinking is, first off, I want to find all the rest of the angles and sides, and I usually start with the angles. There's one left, and if we think through our sum up to 180, we've already used 90 and 60, so there's only 30 left. Or you could just notice really quickly that pattern of you've got a 60 and a 90, we're missing a 30. From there, let's talk side lengths. So in our setup on the original, across from the 60 is root 3. On this one, across from the 60 is 3 root 3. So let's think about this as saying that we have a scale factor where we multiplied by something. So it went from 3 times something to get 3 root 3. It must have multiplied by that 3. So our scale factor was times 3. We can use that to solve for the rest of the sides. So like our bottom side here, it used to be a 1, but now we're multiplying by 3 to get a 3. And our hypotenuse used to be a 2, But now it's going to be a 6 because we multiplied by 3. Now, we could have done this problem with anything sine, cosine, tangent. However, this was much quicker once we get in the groove of things, and I didn't really have to show any work. So that's kind of cool. Let's do another one. All right, so here's what we're given. I'm also going to give us this side is 8 root 3. So let's see, filling in the rest of the angles, this angle must be 60. And then, let's see, we were given the side across from the 30 this time. And the side across from the 30 is normally 1, but this time it's 8 root 3. So in this case, our scale factor, we went again from 1 to 8 root 3. We must have multiplied times 8 root 3. So if we're going to figure out the rest of our sides, we have to use this and multiply each time by that. So let's see, let's do our hypotenuse next. So across from the right angle is the hypotenuse. Normally it's 2, but now it's 2 times 8 root 3. Now it's 2 times 8 root 3, which is 16 root 3. And then our bottom leg across from 60 is normally root 3, but now we're multiplying by 8 root 3. Now let's be careful right here. If we've got a root 3 times a root 3, that's really a root 9. So I've got 8 times root 9, and root 9 is really 3, so that's 8 times 3. So that's 24 for that bottom leg. All right, last example then. And I'll give us this one. All right, so here's what we've been given. We were given the side across from the right angle. The side across from the right angle you can check back. I've got mine kind of zoomed in. The side across from the right angle is normally a 2. We have a 20. So in this case, our scale factor, we must have multiplied by 10. So we'll do that for the rest of the sides. Across from the 30, this is normally 1 from our original, and now we're multiplying by 10, so it's 10. And across from the 60 is normally root 3, but now we're multiplying by 10, so it should be 10 root 3. So that is our setup. We've also got 45, 45, 90s that we'll talk about on day 2. But here is our setup one more time, and I will leave you with that.